Sometimes when you're doing these in the rewind, for example, when you're finding the midpoint, if you're not sure what your signs should be, because a couple people had mistakes on signs, just make sure that if you plot that point, it's actually on the line. So if you had gotten like -1, 1.5, which I saw a couple people get, that would be up here, which wouldn't be on the line, so you know that can't be the midpoint. So it has to be -1, -1.5, because they're both there. All right, can anybody remind me what's the formula we use, or what's the, if you don't want to think of it like a formula, what's the process we use to find the midpoint? X plus X over 2. Perfect. Okay, what's different if you're finding another endpoint? Like, what if, for example, I told you that this is the midpoint and this is the endpoint? How would you find the other endpoint? You can either count or, yeah, you can use this, except you plug in your endpoint for the X and then you equal it to your midpoint. So either way, it doesn't really matter, but I know that since this one's the endpoint, my line is going to keep going up or go down? Down, because this one has to be in the middle. So how many down does it go? 5, so I'm going to go down 1, 2, 3, 4, 5, which would take me from -4 down to what? If I went 5 down from here? -9, good. And then how many over? 4, so if I'm going 4 over from here, where would that take me? 5, good. So your other endpoint would be 5, -9, okay? So again, you can do that algebraically, and we talked about how to do that yesterday, or you can just count. Counting depends on the fact that you have a what? Coordinate plane or a grid. If you don't, what should you do? Make it. You can make it, or you can think of it like we did right here and just like add the numbers on. All right? Okay, so today we're going to talk about not midpoints, but distances. So if I want to know what the distance of AC is, how could I find the distance of AC on a number line? Again, I can just count it, or if I want to do it mathematically, I would subtract. Okay, so I can count and I can say 1, 2, 3, 4, 5 and a half. All right, assume it's a half. So that distance is 5.5. Or I can do 5 minus -1/2. And what happens when it's a negative? Becomes a big plus sign. What's 5 plus 1/2? Just 5.5, right? 5.5. So either way, the distance is 5.5. If we're finding distance, unlike midpoint, we subtract them. Okay, so we subtract to find the distance. And that works out really easily when it's on a number line because there's only one endpoint and there's only one digit to the endpoint. But again, if we put that onto a coordinate plane, what changes now? What changes when you put something on a coordinate plane? It's slanted and it has two what? It has two coordinates, right? There's an x and a y value that we have to consider. So if A is -6, +5, and C is 3, 9, how could I find the distance here? I can't really subtract or count just by itself because I can count and say that I go, okay, well, to get from here over to here, I go 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's true. I go 9 this way, and then I go up 1, 2, 3, 4. But what's wrong with doing it that way? Let me think of it this way. If I were walking over, whose classroom is right over there? So let's say I were going to Miss Chibnall's class. If you guys were walking over to Miss Chibnall's classroom, how would you get there? Yes, walking. I assume you're not riding a bike, but yes, walking. Okay, give me the directions to get to Miss Chibnall's classroom.
You go straight out the door.
Okay.
You take a left.
Uh-huh.
You go straight till you hit the next turn, which is another left.
Uh-huh.
You continue straight, and you take another left.
Uh-huh.
Go straight
And then the bell rang because you're late to class because you chose to go the longest way possible, right? What would be a different way? Down the stairs and across. Would most people go down the stairs and across?
No.
Would most people who want to be on class on time go down the stairs and across? Why? It's the most direct route. Is this the most direct route for how to get from A to C if I go along this green path? No, that's like walking all the way around the U of the building, right? Which you might do if you had to stop at your locker, but if you didn't, the most direct way to get there would be to go along the line AC, right? But we can't find AC just doing this because all I know is that this is 9 and this is 4, and it shouldn't really be 13 because that's too many steps to take. So is there another way that I could figure that out? Does anyone see what shape that makes? It makes a triangle. What kind of triangle specifically? A right triangle, because this would be a right angle right here. So is there a way, oh, that's nice. Is there a way that we can find how long this is if I know that this piece is 9 and this piece is 4? Is there a way you can find this part of that right triangle? Not using the area. How many of you guys have heard of the Pythagorean theorem before? Heard of it. I'm not going to ask you to tell me what it is, just heard of it. Okay, so does anybody know what the Pythagorean theorem is? Desiree? A squared plus b squared equals c squared. That is one of the most commonly used things in geometry. It is one of the most commonly used formulas in geometry. It means that if I add together the square of this side and this side, it equals the length of the longest side. Does anyone know, this is about bonus points, does anybody know the H word for the longest side of a right triangle? Cecilia? Hypotenuse, exactly. So the two legs are A and B. It doesn't matter which is which. This could be A, this could be B, this could be A, this could be B. It doesn't matter. Which one always has to be C? The hypotenuse. So the long slanted one always has to be C. So we can use the Pythagorean theorem to figure out AC, because if I count this, I know that how long is A and how long is B. So to figure out C, then I would just do 9 squared plus 4 squared equals c squared. Well, what's 9 squared? And what's 4 squared? 16. So then what would I do? Add those two, which gives me 97 equals c squared. And I'm almost done, except I don't want to figure out c squared. I want to figure out c. So how do I get rid of a squared? Square root it, exactly. So I square root both sides, and I get c equals square root of 97. Why don't I simplify that? It's not a perfect square, so I'm done. All right? So c is the square root of 97, which means this is the distance right here. If you do that on a calculator, which many of you will, all right, I will recommend that before you go to your boards, grab a calculator. If you do that on a calculator, it will turn it into a decimal for you, all right, and it will be almost 10, so 9 point something. All right, so we would say approximately like 9.9. So the Pythagorean theorem will work every single time. You've just got to figure out the triangles. So basically, you just have to count to figure out your A and your B. So let's take a look at this one. It's the same one. Let's take a look at this one. So if I want to figure out the length of GH, then I need to figure out how long my legs are. Are the dotted lines real? No, but why do we put them there? To turn it into a triangle, because you can't do the Pythagorean theorem if it's not a triangle. So this just turns it into a triangle. Could I do the triangle going this way too? Yes, it doesn't matter which way you draw it. If you draw your triangle on the bottom, that's fine. You can also do it on the top, like this. Okay? And it doesn't matter. So how long did I go over? I went here from -8, -3, all the way over to 7, +3. That looks like a 4. It's not. It's a 7. 7, +3. So if I went from -8 all the way to +7, how many would that be? 15. Good. So 15. And then how many up did I go to get from -3 to +3? 6. You can count it. 1, 2, 3, 4, 5, 6. All right. So then where do I plug that in? What formula do I use? Which one is A? Does it matter? Doesn't matter. Let's make it 15. Which one is B? And then do we know C, or is that what we're looking for? Good. We're looking for C. All right. So 15 squared is 225. 6 squared is equals C squared. If I add those together, I get 261. 261. All right, is that a perfect square? No, so my answer ends up just being C equals square root of 261. All right, this is the step that people forget sometimes. Don't forget to take the square root, because you're trying to get C, not C squared. Sit up, please, Alda. All right, if it were a perfect square, if it were like the square root of 100, then what would you tell me it is? 10. If it's a perfect square, simplify it. If it's not, don't worry about it. Just leave it alone. Just like with fractions, don't make more work for yourself, okay? Leave it as a square root. That's just fine. Okay, so I'm going to put the coordinates up here so that you have them. If you want to come up to the board to count them out, you can. Just be aware that there's 19 of you, so 19 people at the board might be tough. So just be polite to each other, all right? But I'm going to put the coordinates up if you need them. Go ahead to your boards. Try to get all 4 done. Oh, and grab a calculator before you go. All right, so if you do not have a coordinate plane, if I just give you 2 points, one of your options would be to put it onto a coordinate plane and count it out. Another option would be, how can we figure out a formula for this? So if you are the type of person, again, who likes doing things algebraically, then you might like this better. So let's take a look at our Pythagorean theorem again. A squared plus B squared equals C squared. And let's go back for a second to this problem. If this is A squared, A was 15, right? How could we have gotten 15 mathematically? If we did not want to count 15, how could you have gotten 15 mathematically? Subtracted which ones? The x minus the x, right? So in this Pythagorean theorem, instead of writing A here, you could write x minus x squared. So if that's the case for A, what could you do for B? Exactly. Plus y minus y squared equals C squared. But I don't want it, that's exactly the same thing. That's doing it mathematically. Instead of counting it, you can just subtract your x's and subtract your y's, and it will give you the same exact thing. Okay, so if you'd rather do that, or if they give you 2 coordinate points and you don't want to graph it, which I never do because I'm lazy and I don't want to do it, I would use this formula. The only thing is, I don't want it to be C squared, so what was the last thing you always had to do? Take the square root of it. So whatever you get here, you'd square root. And this formula is called the distance formula. So the square root, this is very long. It's also written right here for you. Okay? So The reason that I want to start from here is because when you see this, what's your first thought?
Well, that's hard.
That's hard. I can't do that, right? But you did it. All that you did on the last 4 problems on the board was doing this formula. The only difference is instead of doing the subtraction, what did you do? You just counted it, right? So the only difference is, and I want to take it from here to here because so often people see this formula and they think, I can't do that, it looks really hard. Nothing you're doing is that difficult. It just looks complicated, honestly, just because of the square root symbol. Just because it's a really long square root. So don't let that intimidate you. Don't let that psych you out. All you have to do is x minus x, square it, y minus y, square it, and then take the square root of that. So let's look at an example. Okay, so here's our segment below. And this is at the coordinate -5, -2. And this is at the coordinate 6, +2. So if I don't want to use the Pythagorean theorem, if I want to use the distance formula, which is essentially just the Pythagorean theorem, I'm going to do x minus x squared plus y minus y squared. And then at the end, I'm going to take the square root. Okay, what are my x's? -5 and 6. So I'm going to do 6 minus -5 squared. Plus, what are my y's? 2 minus -2 squared. What's 6 minus -5? Yeah, because all that does is makes it a positive. So it's 11 squared plus, what's 2 minus -2? 4 squared. What's 11 squared? And what's 4 squared? So that ends up giving me the square root of 137, which would be the exact same thing you would get if you had counted out the triangle. Okay? So this is no different. I think when you put a long square root on, people think, oh, I can't do that. It's not that you can't, you just do it last. All right? Why don't we simplify that? It's not a perfect square, so we're done. You're doing this exactly the same way. The only difference is instead of counting, what's the only step I'm adding? Subtracting. Yep, you're putting in a subtraction problem. All right, it's up to you whatever way you want to do them. I find that once you start practicing them, even though the distance formula looks intimidating, it's not actually that difficult to apply. It just looks really long. You don't need to memorize it. You'll have it on any test and quiz. It'll be there for you on any test and quiz. You just need to know how to use it. So that's what that means. X minus x and then square it. Y minus y and then square it. Because it's subtraction, does order matter? Yes. So if you pick this for your x1, then this has to be your y1. So if you start with the 6, then you start with the 2. I always just start with the one on the right. Okay. So let's try to find the distance here. I have no coordinate plane. I don't want to draw one, so I'm just going to use the distance formula. And that's that long square root, x minus x squared plus y minus y squared. Which one do you want to start with? I don't care, but let's start with the 5 because then it's going to make it addition instead of subtraction, which is easier. So that would be 5 minus what? -4 squared plus 8. Good. Micah, how come you started with the 8? Okay. If we start with the 5, we have to start with the... Yep. All right. What's 5 minus -4? 9, because you add them. And then what's 8 minus -12? 20. Good. Because you add them. What's 9 squared? 81. And what's 20 squared? 400. All right. What's 400 plus 81? Is that a perfect square? So do we have to do anything else? So how long is that line? Square root of 481. okay, which is a little bit bigger than 20. All right, so that'll be approximately 21 maybe? Did it just simplify that? You have to change the mode. Don't worry about it. All right, so I would leave it like that. The distance is 481. You're going to see D equals because D stands for distance. But this all comes from what theorem? The Pythagorean theorem. This is just a different way of writing the Pythagorean theorem where we took out the counting and instead of counting we put in subtraction. Okay, nothing's different. Think back to the number line at the very beginning we looked at. We said how do we find distance? We subtract. All right, how do we find midpoint? You add and then divide by 2. Distance you subtract. So that's why there's subtraction here. Okay, but the one in the middle is a plus. But again, you will have the distance formula. Okay, so try 2. Any 2 of these. Try the 2 from the top 4 so that you don't have to count them out on here. Do any of the first 4, but just do 2 of them.